Alright. So we're doing a Half-Life lab today. So to figure out how Half-Life works. And it kind of tells you about Half-Life. But we're using the pennies here to demonstrate. We can't use radioactive stuff because that's dangerous. Have any of y'all seen that HBO series, Chernobyl? It's really well done, but it just makes my skin crawl just looking at all those people. There's so, because I mean that's how it went. There's so many people exposed to radiation in the movie, and it's so rough. It's not a movie; it's a series, but it's a limited series, right? It doesn't have seasons. But oh man. Anyway, we can't use actual radioactive stuff because that's dangerous. So, the way radioactive stuff works is dangerous when it releases neutrons, or sometimes it releases protons and neutrons, and it's bad for you. Excuse me. So when it does that, it changes either its isotope or its whole element. It's not the same element anymore if it releases protons, because then it has a different atomic number. So like, let's say a heads-up penny represents carbon-14, and then it flips over, and then it's whatever carbon-14 decays into. I don't know what it decays into. But we're going to figure out some of that stuff. So what happens is, it's going to have you shake it up. Make sure you have the same person in whatever group you're doing it in. Shake it up. I have 100 pennies in here. Your instructions say 40 pennies, or 40 or whatever you can find. Crackers, whatever. If you have a pack of crackers, and it's I don't know, you can probably make a mess that way. But if you can tell the front from the back, then that's something to do. Or you can tear up a piece of paper and write on, put a dot on the other side of each of them. There's many different ways to find stuff to do here. Why is this one red? Anyway, yeah, I have 100. The more, the better. But if you have 40 or if you have fewer than that, it still works. But as we go through our chart here, it's going to go real fast. So if I dump all my stuff out here, so the heads ones represents ones that are still carbon-14. The tails ones are ones that have decayed into something else. So at 0 seconds, before I shake it for 10 seconds, I would say 100 undecayed atoms and 0 decayed atoms, because they're all still carbon-14 as far as I know. When you shake it, make sure the same person shakes it to make sure that it's shaken. They're randomized about equally each time, and make sure you time it. Then shake it for exactly 10 seconds when you do it, just to make sure that they're randomized equally each time. Otherwise, your difference between 1 and 2 and between 2 and 3, if you don't shake it for as long or have a different person shake it, might be scientifically flawed. So yeah, I mean, it'll probably go 150, 25, something. That would be what we predict. It's a coin flip, literally. But make sure you actually do it and actually count them, because it's not always if we know something's half-life, that's like an average, and we're figuring out what we get here. So yeah, you'll make a table just like this and say so many atoms in so many seconds. You're doing 10 seconds. You've been instructed 10 seconds. The atoms are however many you have. In these metal things, we've got 100 pennies. And let's put the instructions up there. And that should probably help. Yeah, I think that's it. Questions? If you want to wash your hands after the pennies so your hands don't smell like metal, that's okay. please go find one of these metal buckets, and it's going to be a little loud shaking these around. That's going to be fine. And then you can go back to the lab. No problem.